A cola dispensing machine is set to dispense 10 ounces of cola per cup, with a standard deviation of 0.6 ounces. The manufacturer of the machine would like to set the control limit in such a way that for samples of 31. 5% of the sample means will be greater than the upper control limit, and 5% of the sample means will be less than the lower control limit. So we know that this is a two-tailed test because 0.5 is less and greater. First, we want to use the formula from Chapter 9, the confidence interval formula, to find the z-value. So we know that there's 45% to the left and 45 to the right. Go to the z-chart for 4500 and you'll find the z-value is 1.65. 1.65 is then the critical value. And now what you need to do is you need to plug it into the formula found in Chapter 9, which is right here. And we get 10 plus and minus 1.65, and that's going to be times 0.6 divided by the square root of 31, which is 10 minus 1.782 and 10 plus 1.782, and you get 9.82 and 10.818, and that's your intervals for A. So that's the values which the control limit should be set at. And part B is asking what is the probability that if the population mean shifts to 9.5, this change will not be detected. So
now we need to follow the type 2 error formula that it was in our book, and the type 2 error, we're going to follow this formula because it is asking that what it will be the probability that the change will not be detected, means that we will accept the null hypothesis. So when it's actually false. So we're going to follow the formula for the type 2 error, and this is the formula, and we need to go ahead and get here the value. So we know that this is going to be 9.82, that was our how much we're going to allow for our interval for the 1.65 for the z-value, and that's what we found the answer from here when we actually calculated the interval. So we know it's 9.82 to the left minus the shift, that is 9.5 for mu1, divided by 0.6. I'm sorry, divided by 0.6 divided by the square root of 31, because that's our observations in the population. So the total equals to 0.32 divided by 0.77 equals to a z-value of 2.97. So you know you need to do 50% because that's to your left minus the 45.85 for your z-value, and the total will be a probability of 0.0015 or 1.5% that it will not be detected. So beta, it will be a total of 1.5 or 0.0015.
which is the answer for B, and that's the probability that the mean that if the mean shifts to 9.5, the change will not be detected, and that's 0.0015. And C asks, what is the probability that if the population mean shifts to 10.6, this change will not be detected?
Again, we follow the formula for the type 2 error.
And all you do is you just plug in 10.8, which is your other interval, 10.18, excuse me, for your other interval, minus 10.6, which they gave you, and divided by 0.6, divided by the square root of 31, and that equals negative 0.42 divided by 0.1077, and that equals negative 3.90.
Okay, so that your z-value is 3.90, that is more than 50% to the right. So that means that this chance that it will not be detected would actually be 0.0000 because it's more than the 50% of to the right. So that's how we found the value, by calculating through the formula and got the result.